2 months after the Deepwater Horizon sank, leaving its broken wellhead flooding petroleum into the Gulf of Mexico for 87 days, I decided to tour the Gulf Coast. That summer, I traveled along the Gulf Coast twice to film this documentary. I was joined by Bill Powell for the first tour and James Morris for the second. We talked to local residents, businessmen, and university professors alike. I wanted to better understand how the worst man-made environmental disaster in United States history was affecting the environment, economy, and emotional well-being of residents all along the Gulf Coast. My name is Max Anderson, and I'm a documentary filmmaker. Our first stop was at Louisiana State University to interview Dr. Prosanta Chakrabarty. He is the curator of ichthyology at LSU's Museum of Natural Science. He studies deep-sea fish, and in 2010, he discovered 2 species of pancake batfish living off the coast of Louisiana. The oil spill now threatens the newly discovered pancake batfish.
I don't always study fish from the Gulf, but one of the first things that happened when I got here is I happened to discover 2 new species of fish from the Gulf. And those guys are pancake batfish. They're flat and they look like pancakes, but they hop along the bottom, the benthic areas of the seafloor. And so these are really unusual guys, and they eat invertebrates. And so I'm a little concerned about one of the new species, which its entire habitat now is in the region of the spill. It's almost just off the southern coast of Louisiana. And when we collected them just 30 miles off the coast of Louisiana, not too far off the oil rig. So with that limited habitat and the fact that they eat invertebrates, I'm pretty concerned about them. The other problem that we have is that this is not a typical oil spill. This is not like Exxon Valdez, which was a surface spill where the oil stayed at the surface. This is a deep sea spill, and a deep sea spill that's now mixed with dispersants. This is the first time dispersants have ever been used in the deep sea. The deep sea is everything below 1,000 meters, where no light can penetrate, no sunlight reaches below 1,000 meters. It's also very cold. It's 1 or 2 degrees Celsius, and there's high pressure, hundreds of pounds per inch. How oil breaks down with dispersant mix at those temperatures is totally unknown. So what we're finding are these plumes of micro droplets of oil. And we don't know how that interacts with wildlife. And everything from bluefin tuna, which is the most expensive fish in the world that's spawning right now, their eggs and larvae become part of the plankton layer. So those can lose generations because their eggs and larvae are now covered in oil, so they won't survive. So it's really hard to gauge what the impact will be below the surface as well. Lots of these deep sea forms that we know very little about, and they're always gooey, crazy looking things that you never catch with a rod and reel, but you have to trawl in the deep sea for, and they always have big teeth and small eyes and fleshy bodies. And so things like this are really hard to get, and things that most people don't know about. And while we focus on oil-covered pelicans and things that are charismatic megafauna, we tend to not see what's very far below the surface. But those are things that are very important to me too. And the use of dispersants in the deep sea means that the oil is going to stay there for a long time. And a lot of these deep sea fauna will be certainly endangered by that. We may never know how the populations of those species are impacted. This is a good old-fashioned anglerfish here. In fact, the pancake batfish, that first species I showed you, is a type of anglerfish. And these are things that you might be familiar with from Finding Nemo, that has a little bioluminescent lure. And these guys kind of hang in the water column and wait for something to come by to be attracted by that lure. And what they do is, under the cover of night, they come closer to the surface. they feed on things that are close to the surface, where all the energy is coming from in the Gulf. So as they migrate up, now they're moving through plumes of oil. And we don't know how, if that oil gets into their gills, where all the gas exchange is happening, how they can survive that, and how they can navigate around it, or even if they are navigating around it. So it's really hard to tell what's happening below the surface, where in fact the majority of the oil is. So that's my take, at least, on the deep sea oils. Do you want to ask questions based on that?
So as far as fish eggs go and repopulation, what are the chances that even eggs could survive through this? I mean, is there any way that that's even possible?
Well, the most vulnerable things are the smallest things, the invertebrates, the eggs,
Okay.
the larvae, the young.
So that's what it would affect first, an oil spill? Okay.
So they've spilled more than 1 million gallons of Corexit, two forms. One's more biodegradable than the other. And at the surface, that's been done before, and it breaks down with sunlight. So, maybe that's okay. But in the deep sea, I don't know how it breaks down. And it's also toxic. It's something that you want to avoid. It can break down, but you don't want to drink a glass of it. Corexit's illegal in England and Europe, so why are we using it? Is there an alternative? I don't know. We do want to keep the oil away from marshes, but that doesn't mean I want to keep it in the deep sea either.
Hydrocarbons that are derived from the oil that is broken down by dispersants could be eaten by filter feeders or plankton. How could that get into the food chain?
Well, the plankton's the top level of the food chain, so whether it be alive or dead, the plankton, if it's consumed, then the larger animals are consuming oil as well. So through bioaccumulation, that can the larger animals. Although larger animals directly eat plankton too, so up and down the food chain it's better.
And that could possibly get food consumption as well.
Yeah, but that's a sticky subject.
Oh yeah. Just for legal reasons, or
I could say what I want, but
say what you want.
I don't know. I don't know. Well, I don't know. I just don't know how much oil could get into the fish that we're consuming. I really don't know. It's not like we found tons of fish and we know that they died because of oil consumption. We just haven't found it. One of the causes of distress for me was that BP was using the estimates of surface oil for their overall estimate of oil coming out of the wellhead. And that early estimates were 1,000 to 5,000 barrels a day. Then they released, after a lot of pressure, video of the wellheads. And then estimates were much higher, into the 60,000 barrels a day. I think the responsibility should now be to make sure that all deep sea oil rigs have the relief well drilled a priority before you have a spill. That was the solution for the 1979 spill, and that's the solution for today's spill. So having a relief well built a priority would help, and that would take the government to say that the Canadian government asked for relief wells to be drilled a priority, so I don't see why we can't. It would prevent disasters like this. So, that's where I think the role of government is in regulation. Next year, you won't see oil-covered pelicans either. Right? By next year, most of the oil will be dispersed in a way that we won't see at the surface. What I'm worried about is that people say, "Oh, look, told you, not a big deal." Well, the big deal for me is below the surface, and then the long-term impact. But it's going to be really hard to gauge the true impact of the spill. We probably will never know. We'll never even come close to it.